Good morning. My name is Sabrina, and I'm going to go over global winds today. So you can see a couple topics we're going to cover on the side there, and we'll first go over basic convection theory. So sounds like a really big, scary name of something, but really it's pretty basic. So convection is caused by the expansion of a liquid or gas due to its rise in temperature. So what happens to warm air when it gets, or what happens to air when it gets warm? What does it want to do? Expand, and what else does it do? It goes up. You got it back there. It's pointing for me. So it goes up. So the material becomes less dense and it rises, right? Expanded and it got hot. It went up. So then when it gets cold, so now that warm up air got to its good level point, we talked about the lapse rate, it went up, cool, and then now it's gotten cold. Now what does it want to do? Wants to go back down and sink. And what does it do as it comes back down? Kind of condenses. So this just kind of starts this cycle of warm air going up, getting bigger. Well, the air mass stays the same, but the particles kind of spread out and it expands, right? And then it wants to come back down because it got cold. There's some good pictures in the aeronautical handbook, or the Pilot's Handbook of Aeronautical Knowledge. I can't seem to ever get those words all in the right order. But there's some really good pictures in there, and then we'll draw some more here as we talk about global winds, and you'll see that convective current as it happens as a whole on the Earth. And then we'll talk about what else affects that. So that's kind of the basic idea for convection. The sun is, the reason we have convection is because we're near an energy source. What is that big bright thing that we can't see today, but usually pops out? It's been out for the last couple weeks. We were just talking about it. That sun is out there and it's warming the Earth's surface, and different surfaces are going to heat differently. So water is going to heat differently than land. Certain parts of land are going to heat differently, so it's going to cause different bubbles of warm air, and that's how convection currents happen, which we talked about in the previous lesson. But global wind patterns is the next one. So that's the basics on that. Global wind patterns. So the Earth's surface, like we just said, is heated by the sunshine. And it causes a circular motion of the wind. So warm air, this is the equator. Warm air is the equator is getting heated first based on the way the Earth is tilted and how the sun hits the Earth. So the equator is the closest part, and we're also a sphere. So if an object were out here heating the Earth, this is the part that's going to get heated first, right? So because of that, this air is getting warm, and it's going to rise, right? Like that's what we just said warm air wants to do. So it's going to rise. Let me use the right colors here. So the warm air is going to rise, and then as it spreads out, it's just gonna spread out, and it's gonna become less dense. Now, as it does that, it's gonna have to come back down. So now it's gotten cooler, and it's coming back down. It's gonna float back down to where it started from. So that convection just creates this nice circle of airflow. And it looks pretty easy to draw right now, but there's something really big that's affecting this airflow, and we'll get to that in just a second. So we'll get to that right now. So basic global wind pattern. The air is gonna rise from the equator where it's the warmest, and then it's gonna move outward, and then as it cools, it's gonna sink back down and come back to where it started. And then it's just gonna start that process over again. So it's just this kind of circle pattern of wind. That's the basic. Now, that's without anything. So if the Earth was just not moving, the big ball is just sitting out there. But what is the Earth doing? What is the Earth doing?
Rotating.
Spinning. Spinning so fast we don't even know it's moving because we're so minuscule in the grand picture of the Earth, right? So we can't feel that spin, but it is spinning. And because of that, we get something called Coriolis force. So the Coriolis force is just created by the rotation of the Earth. And in the northern hemisphere, which is where we all live, right? This is the northern hemisphere where we all live. Air is going to be deflected to the right. So north equals air to the right. And the south is going to be exactly the opposite. So that is, and it's going to be greatest at the poles and near zero. So greatest at the poles and near zero at the equator for that deflection. That's the basic Coriolis force, but now there's a 3-cell model. Again, a name, but all it's doing is taking that global wind pattern and showing you what's happening to it because of that rotation that the Earth has. So the Coriolis force is causing the wind, and it happens to fit right into very, very nice numbers for us. So at 30, 60 degrees of latitude is where these things are going to kind of take place every time. So that warm air, once again, is going to rise up. And in between 0 and 60 degrees, so between 0, set that backwards, sorry, let's get that right. 0 to 30 degrees, the warm air is going to rise and do what it had been doing before. It's going to travel north, right? That's what we just showed it doing a second ago. And then about a third of the distance, it's going to cool. So now it's cooling, and now it's going to sink back down, just like it did before. And then it's going to start that pattern. So now you have a circle pattern here. And the same thing is going to be true, the same circle pattern is going to be true between 60 and the pole, 60 degrees to the pole. And this gives us a easterly trade wind. Has anybody ever heard of an easterly trade wind before? This isn't in an area where we live. We live in this, well, in the United States we fall into, and I'm guessing most of Europe falls into the 30 to 60 latitude range. So we have a little bit different wind flow. But if you've ever heard anybody on the news or anybody talking about an easterly trade wind, that's what that is. And in one of the next lessons, we'll kind of talk about how those affect high and low pressure systems and changes in seasons as well. But just for right now.
I went sailing down in Dominican once.
Did it?
And
Really?
yeah, we had an easterly trade wind, like the whole time it blew one direction. I mean, it would, like during the day it would pick up, and then the evening time it would die back down. But that was awesome.
Yes, that sounds awesome. I've been sailing in Kansas. Not quite the same. So this constant deflection there is going to give us that easterly trade wind. So wind's always going to be getting pushed to the east in this latitude. So east wind. So what's happening between 30 and 60 degrees? If it's going east in 30 to 60, and it's an east wind in the 60 to the pole, is that 90? The pole, 60 to 90? It didn't give it a number, it just actually said the pole, but in the books. But so between